So there was a lot of science already in the previous talk, and that's great. But that's mostly science that is out of our control. This is what the hospitals are doing, the government is doing, the researchers are doing. There's also a lot of people currently working, pretty much the same field, providing all the medicine to the people that need it right now. And they need to be up to date with things as well. So there's kind of like these two parallel industries that are currently happening. My talk is going to be in 4 chapters. The first one is about CBD strains and clones, the difference and why we have problems in Australia with that. The second part is extraction methods and solvents. I mostly put that in there because I noticed last year pretty much most of the questions were about how to extract things. Something that doesn't get mentioned very often is cannabis essential oils, the terpenes, and just finally just a little wrap up about the medical literature. So we'll start off with the difference between strains and clones. Strains are grown from plants from seed each generation, which means you have to grow flowers, you need to pollinate them and produce seed, and then start the cycle again. You need to also make sure that you keep all other pollen out. Whereas on the other hand, clones are always grown from one plant, and you keep on taking cuttings and propagating from the same plant. The clones can be low-tech or high-tech, so low-tech will be just doing cuttings, high-tech will be using a tissue culture protocol. Strains, the individual plants within a strain will have similar characteristics, but not necessarily be identical. So there will be some variation, which makes it more difficult to predict what your product will be like. With clones, you have identical genetics. Every single plant is genetically identical. And the only influence there that changes what your final product would be is environmental conditions. So, whether you grow it at different times a year or... reasonable stability in a strain doesn't sort of happen until about 4 generations, or usually 4 years for that. Whereas with clones you have instant stability. Every clone is genetically identical. So if you want to model what your next year's yield will be, you can do that from a clone, but you can't do that from a strain. Genetic diversity in non-target characteristics such as pest resistance, fungus resistance. You do get that in a strain because there's slight differences, but in clones you don't. So clones, sometimes you get whole crops wiped out. It's one of the things to consider when you're choosing between the two. So with a strain, you select the female, and then you select a male that hopefully has similar characteristics. You produce a whole bunch of seed, you produce a whole bunch of seedlings, which are both male and female again, so you're kind of wasting half of your resources, and then you start the whole thing over from the beginning. And that takes usually a 6-month cycle. With clones, as a low-tech, you start off with a female, you take cuttings, you root the cuttings, you take more cuttings off the rooted cutting, you produce lots of them, and then you grow them in a grow room. You have to keep them under lights though, because you have to stop them from maturing. Otherwise you can't take cuttings anymore. The high-tech version would be to do tissue culture. So you grow a plant that has the characteristics that you want. You then take cuttings from that, you sterilize them, put them into tissue culture, and produce lots and lots and lots of those. And then you have to not just light control, but also temperature control your plants. So it gets a little bit more complicated. So there's a trade-off between how much you put in and what you get out of it. So one of the most interesting strains when you're talking about CBD strains and CBD varieties is Cannatonic. It's an unstable strain. It's actually only a hybrid. A lot of seed gets produced every year of it, but most of that seed is actually just high THC, high CBD seed, which doesn't really help if you're selecting for low CBD. Now, the problem is in Australia, you need to grow, the only way you can grow hemp here, thank you. The only way you can grow hemp here is if your product has less than 1% THC. And to be able to reuse that seed, you would need to have less than 0.5% THC. So that becomes quite difficult because generally most high CBD strains still have more than 1% THC in it. So Cannatonic was really interesting in that respect because even though it produces like 90% of these first two and probably 9% of that one, it also produces like 1 in 100 of this one, the low THC high CBD, which is the one that pretty much all high CBD strains are derived from, whether they're clonal strains or a variety of strains, doesn't matter. So ACDC was the clone that I don't know whether Abe actually mentioned the name earlier, like 2 talks back. That's what they use in Colorado as the high CBD strain there. Valentine is another one that's used in Canada. Wiedemann was developed in Israel. That's the one, the main CBD producer in Israel in the research. And Z7 apparently just found its way to Australia. So that's probably most CBD strains in Australia will probably be based on Z7. Now Z7 is interesting because it's not actually just a single plant selection out of this individual or out of these seeds. It's actually another cross. So they've taken an individual out of this, crossed it with some other random selected high CBD individual and ended up with a Z7. So in practical terms, if you want to start a CBD industry in Australia at the moment without government approval, seeds have to be either imported legally, so you have to go through all the paperwork, or easily smuggled. It's much more difficult to get a clone into the country not just because of the customs approvals, but also because of quarantine, where seeds don't know any of that risky with quarantine. Seeds proliferate about 1,000-fold per every 6 months. It sort of depends on the size of the plant and the strain. But if you can get 1,000 seeds out of a plant, then you're doing well. Cuttings proliferate about 100-fold every 6 months. That's if you keep on taking cuttings and you keep them at ideal conditions. However, if you run it in tissue culture, you can get about 7,000 in 6 months. So going back to the previous processes, there are good reasons to pick any one of these. Bulk seed harvest is often contaminated with wild pollen, especially in this area. If you're trying to grow a low THC crop here, there's always a boy flowering somewhere within 5 kilometers. The seed will eventually be contaminated, so you'd have to do very controlled pollination. Cuttings and TC clones always stay true to type. They can't get contaminated. Cost per baby plant is basically the cost of a seed. And cost per baby plant for tissue culture is at least $1. In small scale, like if you're starting off with just one plant and you want to do the first 100 or the first 10,000, you're probably looking more like $5 to $7 per plant. From seed you can get useful biomass in the first year, so that makes it very attractive if you're a farmer and you want to produce crops straight away. Whereas you won't get useful biomass until the second year if you're using TC clones or cuttings, because you still need all your plant material to propagate from. Otherwise, the exponential rate that you're proliferating at drops back down to 1. So the state of high CBD strains and clones in Australia is that we just don't have any. In the US they have at least 3. They got Charlotte's Web and they got ACDC, and they got a few other Cannatonic derived clones. That the whole market over there is basically from them. Same thing in Canada and Europe and Israel. Plenty of high CBD strains that are well below 1%. We can't import these into Australia unless we're part of a big pharmaceutical company that's got the approvals for it. So At the moment, Australian CBD production is entirely based on low-yielding hemp. So you're looking at 1% CBD in hemp, whereas the AC/DC strain, for example, is 18% or thereabouts. So you need to extract a lot of hemp using a lot of solvent, a lot of processing to be able to get a certain quantity of CBD at this point. The more like if your plant contains 16 times as much CBD than a industrial hemp plant, then it means you use 16 times less solvent, so, which makes it a lot cheaper. So Australian producers are selecting their own high CBD strains. It seems to be at the moment we're hovering around the 6 to 8%. So we're still only about halfway to our counterparts in the US and Europe. Hence the high CBD herb that you can actually just use as the herb using the normal processing methods that you use if you only want CBD. Your butter, your oils, your butane extracts, whatever that might be. That herb just won't be available for a few years because we're only just at the 6-7% mark, and we need to get the much higher strains to make it worthwhile. So, as with always with market forces, initially for the first couple of years, a high CBD herb will probably be very expensive, and the high CBD herb in Australia will have a different profile to the ones overseas because they won't be exactly the same clones. Because we'll be growing them from Australian single seeds and then selecting from that. So moving on to cannabinoid extraction methods. The cannabis plant actually we're only going to focus on THC, CBD, and CBN and their acid derivatives. The plant actually only makes the THCA and CBDA out of those. The THC, CBD, CBNA, and CBN are all derived from the other two, usually by degradation through UV or just time. THCA is not psychoactive, so it's attractive for potential commercial medicinal use. There's a few people in Australia looking at that. However, THCA and CBDA are poorly researched at this point for what effects they have. So you can't just go, THC works, let's use THCA for the same thing. That may be completely different. As was shown with CBD, CBD is effective against breast cancer cell lines, and CBDA was not. So like I said, the two cannabinoids out of that set that we're looking at that the plant actually makes is THCA and CBDA. THCA has low THC psychoactivity. Time and UV and heat can turn that into THC, which is why you get stoned when you smoke it, or after you bake it and expose it to heat. If you wait longer, more time, more UV or more heat, you end up with CBN, which has almost no psychoactivity except for that it's very sedating. So it's actually used as a sedative. CBDA just converts to CBD. Which is extremely stable. So there's no third compound that it degrades to. Now the degradation is a combination of heat and in the lab, if you're doing cannabinoid extraction in the lab, the degradation from THCA to THC is a combination of heat and time. So the higher the heat, the shorter the time. Going for the lowest temperature, 120 is actually the lowest temperature, but 130 makes sure that it actually happens. And it's also the same temperature that CBDA will also degrade to CBD. Now the problem that a lot of people find themselves in is that they get that they want a THC CBD 1-to-1 product. So they want equal amounts of THC and CBD in their resin or in their herb or whatever they're using. The problem with that is that if you start with the plant material and you want to create the THC, you only have to heat that for 20 minutes at 130 degrees. Now, at that 20-minute mark, almost no CBDA is converted to CBD. So you've maximized your THC, but you're not getting a lot of CBD. If you maximize your CBD, which means you run the whole thing for about an hour, then most of your THC ends up as CBN. So you end up with a product that's CBN and CBD, but virtually no THC. So when you're doing extractions, you have to consider all of these factors, because the solvent that you use or the method that you use also determines the temperature that you're going to use. And the 130 degrees on the previous slide isn't the only temperature that this happens at. They already start converting at 70, 80 degrees. So if you're using ethanol, for example, as your extraction solvent, and you're boiling off the ethanol via the Rick Simpson method, you're actually converting a lot of your THCA and CBDA already into THC and CBD. So yeah, if you're using the high temperature method with boiled ethanol, for example, ethanol is a very popular solvent for this. It's hard to source and it's expensive to get food grade, but it gives you a very psychoactive and sedating product. If you wanted to do the same thing without boiling it, so that would be up here, which would be the low temperature method, you then need to consume the alcohol with it. So a lot of people with cancer don't want to consume 50, 100 mil of tincture a day. So they're kind of stuck there between this choice and this choice of not actually not being able to take the THCA, but actually having to take the THC instead, or going all the way to CBN. The other solvent options for low temperature would be some sort of solvent that evaporates at very low temperature. Acetone, ether, butane are the more commonly used ones. Butane is your butane honey oil that a lot of you would be familiar with. It's great because the butane evaporates at room temperature, so you don't have to heat it at all. So basically your cannabinoid profile of your final product is exactly as what was in the plant, which may or not be a good thing if you actually want THC instead of THCA or CBD instead of CBDA. You might have to heat it just to get to the right profile in the end. The other high temperature method is down here, which would be the coconut oil, the butter kind of methods. Again, the drawback is that they can't be smoked, but also because of the high temperature, all of it would be converted. So you would be dealing with a CBN CBD product. So here's just a list of conditions that might be treatable with these different cannabinoids. That's just to show you that it is actually important to decide what you want. So a lot of cancer patients want THC and CBD in a 1-to-1 ratio. They don't necessarily want CBN. Other people who want to go to sleep, they don't want THC, but they want lots of CBN because it's a sedative. So these previous production processes and solvent choices let you decide which one of these you'll have. I'm just going to rush through this next section because apparently we're running late. One of the things that's often not mentioned is the essential oil or the terpenes. Now, the essential oil has a synergistic effect with the cannabinoids. They also act directly onto the cannabinoid receptors. They don't just support the cannabinoids themselves, they actually act directly onto the receptors as well. The essential oil is responsible for the smell of cannabis, so you can usually tell a high essential oil herb by how good it smells or how bad it smells. Many cannabinoid extraction methods actually remove the essential oil. So anything that involves boiling, you'd be removing most of the essential oil. So your this Rick Simpson method, for example, the essential oil is mostly gone out of that. the view of having a whole plant extract isn't just a naturopathic sort of view. It's actually backed by science because of these interactions between the essential oils and the cannabinoids. So here's just a list of how to maximize essential oil content, or how you lose most of your essential oil. So to maximize, use fresh material, gently dried. Don't heat it over 80 degrees at any part of the process. Use low boiling point solvents, such as the butane method. If you're using alcohol, don't evaporate the alcohol. Avoid smoking the product, as this then simply burns off the essential oil. For minimizing, you would use old herb, boil off the alcohol. One thing to point out is that commercial extracts where solvents are recovered, usually the essential oil stays in the solvent in the recovery. So you're not getting it in your product. They keep it in the alcohol or in the solvent. The CO2 extracted products, especially the CBD that's available, supercritical CO2 extraction CBD, is usually devoid of essential oil. So you have to look for the labeling or ask for the process to make sure that it is actually a terpene-rich product, because you can set the CO2 extraction to also take out the terpenes at the same time. Not going to go through this table. This was just to show that there's a whole lot of components of the essential oil, but there's only two major ones: the myrcene and the caryophyllene, which you can see have a synergistic effect with CBD, and THC, both of them. So it's actually important to have them in your product. Right. Just as a summary, there's enough human trial evidence to support cannabinoid use for autoimmune conditions such as psoriasis and Crohn's, anxiety, pain, nausea, appetite, inflammatory conditions, and I forgot one. There's plenty of human anecdotal evidence to support animal trials and mode of action data to support cautious use into urgent research into epilepsy, psychosis, diabetes, and asthma, as was talked about by the previous speaker. However, no matter how much you look at Facebook, all the memes that come up on Facebook about how cannabis cures cancer, there is actually no proof of that at this point. The animal models are encouraging, the pharmacological models are encouraging, but there is literally no evidence at this point. Hopefully, by having better products available by manufacturers, as in black market manufacturers, knowing about the problems I outlined in this talk about the different cannabinoid profiles, and hopefully by them being able to market their product with analysis certificates in the future, because they become more aware of these problems, we can get more reliable data. That data would also help with the surveys that Nick was talking about earlier. Most claims about cannabinoids are based on cell line research, which is usually badly misinterpreted by people who use it on social media. Cell lines is basically just cells in a tissue culture, in a culture tube, and they put a unreasonable amount of a compound on there, and most compounds will end up killing the actual cells. Salt will, caffeine will. So, just because caffeine kills cancer cells doesn't mean that we all believe, we need to drink more caffeine to get rid of, the breast cancer or something like that. So be careful about the information that's provided to you. Be critical about it, because most of it is misinterpreted.
Wow, thanks, Torsten. Yeah, there's I don't know, suddenly this afternoon's getting really, really full of information. Hey, wow. And thank you for doing that so quickly. Yeah, we've got to keep moving through, because at some point outside it's going to be really, really noisy. And last year we had poor Dr. Behrman talking while all that was going on. And of course we have to go and check out important things like the Combi Convoy. Anyway, is there any questions for Torsten? We'll just do one, and then otherwise I'm sure all the geeks would love to get together and chat afterwards. So has anyone got anything? Wow, we might.
Cool.
Yeah, great. Okay, great. Thank you very much, Torsten.
I'll be around anyway. Okay.